All right, let's go ahead and get started. So today, we'll go ahead and start into the math review. As I said on Tuesday, I always like to start every one of my physics courses every semester with a math review. I go through, personally, I'll go through all the topics that I'll be covering in the semester, try to figure out, what kind of math is going to be used for all the different topics. And then the first week or two of class, I do nothing but go over those topics of mathematics that you will be seeing throughout the semester as a means of making sure that if there's any issues, any lacking, anybody who's it's been a while since you've taken the math course such that basically I'd rather take the time to concentrate on the math now when it's purely math rather than when we get into physics and we're having to learn the concepts of physics and all of that and the equations, how to use the equations, and then have math issues crop up that complicate matters further. I'd rather get the math issues out the way now. If you had a poor math teacher in high school that you didn't really get much out of trigonometry, or you did learn it, but it's been a few years and you kind of forgot the difference between sine and cosine and things like this. Let's go ahead and review them now, get it fresh in our mind. And then when we start into the physics, we can concentrate in the physics topics, and the math is just a tool we can use along the way. So for this particular course, we're going to be learning mostly using algebra. A little bit of trigonometry will be required because there will be a little bit of vectors along the way. And of course, if you took first semester physics, you saw that vectors can be an important part of physics. And in order to work with vectors, you need to know trigonometry, at least parts of trigonometry. And so that's the kind of stuff we'll go over. And so firstly, let me go ahead and talk about algebra. So with algebra, obviously, there's tons of theory and mathematical stuff dealing with algebra. There's not just the basic algebra you learn in high school and college algebra, but of course, there's more advanced forms that you can get into depending on how far you want to push your scientific knowledge. You can get into things like linear algebra, which takes the concept of vectors and makes it more bigger thing called matrices, or even bigger than that, tensors. That's the biggest there is. And so how to use vectors and matrices in solving kind of complicated algebra problems. And specifically, those problems are, 100 equations with 100 unknowns and things like this. Do we have techniques which make solving those types of problems, which we could do by hand using basic algebra, but obviously that would take a really long time to do. Do we have more advanced techniques that allow us to do it in a more efficient manner? And then there's abstract algebra, which goes further than that, and so forth. So algebra is a very, very big topic. And even the algebra you learn in high school, there's more to those classes than what we're going to use in physics. And this is true for any mathematics course. Obviously, math is a huge subject, and only some of it will we have to actually use for the particular topics we're going to be discussing. So when I talk about algebra for this course, first thing I mean, of course, is basic algebra. Set up an equation. That equation has some variable in it, and you want to solve for the value of that variable. So for instance, you could have something like 2x plus 5 equals 15. Nice basic algebra problem, and I'm sure everybody here knows exactly what to do to solve this. If it were me and I were teaching a formal mathematics course, what I would say is you always want to get the variable, the thing you're trying to solve for, by itself and all the other numbers on the other side of the equation. Now, formally, what a math teacher would say is, all right, when I see this, here's the variable, the x part is right here. So I don't want to mess with that. So what I'll do is I'll bring the 5 over, or I need to get rid of the 5 that's on the left side of the equation. So in order to do it, you have to subtract 5 on the left, right? And if you subtract 5 on the left, the plus 5 and the minus 5 will cancel out, and you're left with 2x on the left side of the equation. Good. However, in order to make the equation hold, that is to say, the left side of the equation equals the right side of the equation, well, we just modified the left. And so if we modified the left, we better modify the right to make sure it's still equal. So since I subtracted 5 from the left, I better subtract 5 from the right. And when I do that, I get 10 over here on the right side of the equation. Good. Now, again, I want to get x by itself, but there's that 2 sitting there. And so I need to do something about him. I would say, well, I need to divide by 2 on the left, and dividing by 2 will cancel it. And so I'll have just an x by itself on the left side. But again, I modified the left, so I better do the same to the right. Divide the right side by 2. And so that leaves 5. And now you see I have the answer, x equals 5. Now, what I want to point out here is while everything I said and did is correct and perfectly fine and exactly what you would learn in a high school algebra class, this is not how I think about solving this problem. The steps may be the same steps I go through, but my thought process is different. And at first, it seems like a meaningless distinction. Why are you telling me about, well, I don't really think about it this way, even though I do the same thing? What does it matter? Well, you're going to find out why this matters, but I'll show you what I think about when I solve an algebra problem like this. So same problem, 2x plus 5 equals 15. Now, for me, what I say is I want to get x by itself to solve for x. How do I do it? Well, anything that's not the variable, I move to the other side of the equation. So you have 2 sides of the equation. One side is the unknown variable. The other side is everything else in the equation. Whatever it is, I don't care what it is, it all goes on the other side. So I see this equation, I say, okay, there's the plus 5 sitting there. I need to move it to the right side of the equation, get it on the other side. I don't want it on the left side. So when I move it, it becomes negative because when you move something to the other side of the equation, it changes sign if you're doing plus and minus. So now my equation becomes 2x. That didn't change. I didn't do anything with him. I just moved the 5 over. So now what do I have is 15 minus 5 over here, which of course 15 minus 5, I know that's 10. All right, now what? Well, on the left side, I still have a problem. I don't have x by itself. There's a 2 sitting there. Well, I don't want the 2 there. So again, I want to move the 2 to the other side of the equation. So in order to move it, because it's multiplying, I have to do the opposite, which is divide. So I divide it over to the other side. So that leaves me with the x by itself, and over here, 10 over 2, which is 5. Okay, so you see, each step is the same. On the left side, the first example, first step was I subtracted 5 from the left, and because of that, I subtract 5 from the right. And in my example on the right side over here, instead of doing that, I mean, yes, I subtracted 5 from the left and subtracted 5 from the right, but the way I thought about it was I moved that element, that thing, the 5, I moved it to the other side of the equation. And again, the last step, there's the 2x, but I don't like the 2. On the first example, I divide by 2 to cancel, but because I did it on the left, I have to do it on the right as well. And in my example, I'm thinking about it as moving the thing over to the other side of the equation. And when you're multiplying something originally, to move it, you have to divide. You do the opposite thing. Now, why is this important? This distinction between what I'm formally the operations involved versus the thought of it being more like I'm manipulating or I'm moving things in the equation. Well, it's important because in physics, what we're working with are equations. And generally speaking, these equations don't have numbers in them. So I'll have something like this. X is V naught t plus 1/2 at squared. So you've taken first semester physics. You've seen this equation before. This is the equation, the kinematics equation. And you can see, yeah, the 1/2 is there, but for the most part, everything is a bunch of variables. And so let's say I want to solve this for V naught. I want to solve what is the value of the initial velocity. How would I do it? Well, the way I think about it makes this quite easy. I think V naught is the variable. Everything else I don't want, and everything else I have to move over to the other side. So this thing, this 1/2 at squared thing on the right over there, I don't care that it's 1/2 and then it's an a and then it's a t squared. It's just something. It's one element. It's a value, a number. If I plug into a and I plug into t and I multiply everything together, this would be some number. But right now it's not. It's three different things. But I don't care about that. See, if I were thinking about the formal mathematical process, I would say, okay, well, yes, I'm adding here, but all of these things are being multiplied. So do I subtract it over or do I divide it over? How do I handle this stuff? But thinking the way I think about algebra in terms of manipulating and moving things around, if I think about 1/2 at squared as a single thing that I could get a value for later, but I don't care what the value is, I'm going to move that thing to the other side. So that thing, 1/2 at squared, currently is being added over here. So if I want to move it to the left side, it becomes subtracted. So now what do I get? X minus 1/2 at squared. That's on the left side. And now the right side just has V naught times t left over. So I moved this thing over to the other side of the equation. Again, I want V by itself. So I got to get rid of the t. How do I get rid of the t? I'm going to move the t over to the left. So V naught will be x minus 1/2 at squared over t. Again, I brought it to the other side of the equation. How did I do it? Well, because the t is multiplying, I divide the opposite operation to move it over. And so now, here's my answer. If I want to know what the initial velocity is, it's that thing. Now, if I were reading a problem, I'd have the numbers for all of these pieces. So I'd stick in the distance and the acceleration and the time, and I'd get a value. But until I know the value of those things, all of these things are a bunch of variables. And I have found that when students start thinking about algebra like this, where you're not adding or subtracting from both sides, but rather you're moving things around in an equation, you're manipulating the equation by moving them, then working with variables without numbers becomes a little easier. You can see what it is you're doing. And you don't have that kind of confusion about over here with the 1/2 at squared, do I divide the a over because it's being multiplied? And so I divide a over here. What do I do? Instead, if I think about, I want V naught, so everything else I have to move to the left side. All of this stuff, this 1/2 at squared thing, is a single object that I'm going to move to the left side. How do I move it? Well, it's currently being added. So to move it to the other side, I have to subtract it over. So that's algebra. That's basic algebra. Here we have an equation with one unknown in it. and that unknown is raised to the first power. How do you solve something like that? You rearrange the equation, moving the terms around until you have the unknown by itself and everything else on the other side of the equation. Now, that's one form of algebra that we need for this class. That's the basic, and that's the most important. Everything we do in this class will involve equations, and every equation you have to solve with algebra. However, there will be other things that complicate matters a little bit. For instance, take exactly the same equation, x equals v naught t plus 1/2 at squared. And now let's say what I'd like to calculate is t. I want to know the time. So maybe I'm at the top of a cliff. I'm going to drop a rock from the top of a 10-meter high cliff, and I want to know how long does it take for the rock to hit the ground. Well, that's what this equation can solve. X, that's the distance the rock is going to fall. A, that's the acceleration due to gravity pulling the rock down. V naught is how fast the rock was thrown from my hand initially. And of course, t is the variable I'm looking for, which is the time of flight. How long does it take to hit the ground? Well, this is a little different because now all of a sudden, my unknown variable, the thing I'm trying to solve for, first of all, is raised. There's two pieces of it. There's a t here and a t here. But then secondly, one of the t's is raised to the second power. And that means this is a quadratic equation. So how do I solve a quadratic equation? Well, if you're taking a formal algebra class, you have two methods. The first method is to try to factor the equation. And I'll say, forget that. We're not going to factor equations here, at least not when it comes to a purely quadratic equation. We're not going to factor them. Rather, we're going to use the quadratic formula. And the quadratic formula goes like this. Given, so I'll do it over here in green. Given an equation of the form ax squared plus bx plus c is equal to 0, where x is the unknown variable, the thing you're looking for, and a, b, and c are just numbers, values of some sort. This is a quadratic equation because notice the variable you're looking for, highest power, is 2. And then there's a linear power, the x by itself without the 2. And then there's a term without an x in it. So there's 3 terms. One is quadratic, one is linear, and one is just the constant number. Given an equation of this form, the solution is that x is equal to minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, so given the standard equation, here's a formula that you could plug the numbers from that equation into, and that'll give you an answer. And in fact, what it'll do is it'll give you 2 answers. And the reason I know that is because of this plus or minus thing right here. This is actually 2 different formulas that's written as one. One formula where you use the plus and you plug in all the numbers, you use the plus and you get an answer. There's one answer. The other answer is when you use the minus instead of the plus, and you plug all the numbers in again, use the minus sign instead, and you get a separate answer. And of course, you need to get 2 answers because math says when you have an equation and the unknown variable, whatever his highest power is, in this case, it's 2, it's x squared, that's the number of answers you should have. So if I have an equation where it's x to the 4th, I'm going to have 4 answers. X to the 16th, I'm going to have 16 answers. Here is x squared is the highest power, so I'm going to have 2 answers. And that's how you solve, generally, a quadratic equation. And so we could do the same with our example over here on the left. First thing I have to do is I have to get this equation here in that form. It has to look like this in some way. So firstly, the x squared, the x, the unknown variable, here we're calling it t, but it's the same thing. T or x, doesn't matter. So first of all, I have the ax squared. So 1/2 a times t squared. So this thing right here is like our a part. And then the next term, I've got plus v naught times t, or this v naught thing here is our b. But then our c, notice we don't have a c sitting over here. And we don't have 0 on the other side of the equation. So first thing we have to do is bring the x over to the other side. And when we do that, it becomes minus x. So let me put a little minus sign here. Not x. Yeah, x. I'm sorry. Is equal to 0. So now this minus x part is our c. So now you see, we've taken our original equation. We've made it look like the standard form, ax squared plus bx plus c. And now we just use the formula. We say, okay, we know what things are a, what things are b, and what things are c. Notice, by the way, our c here includes the negative sign. You cannot get rid of the negatives here. The standard form assumes everything is positive. But if you have a negative in your term, then the negative goes along with the variable, the a, the b, or the c. All right, so there we go. All I do, plug it into my equation. So t is equal to minus b. So minus, what is b for us? V naught. Plus or minus the square root of b squared, v naught squared. Minus 4 times a, well, what is a? 1/2 of a. Times c, our c is negative x. All divided by 2 times a. So 2 times a, and a is 1/2 a. And there we go. There's my formula. And from here, obviously I could simplify it down. I can multiply everything through and all of that. What would I have to do? Read the problem, get the data from the problem that tells me what was the initial velocity, what's the acceleration. I plug the numbers in, plug it in my calculator, and I get my 2 answers. Okay, so quadratic formula. Given an equation where the unknown you're looking for is quadratic, and it's of the standard form, quadratic form, this is how you solve a quadratic equation. Now, don't be fooled, because you can get an equation that looks like it's quadratic, but it's not. For instance, let's say we have this equation, x equals v naught t plus 1/2 at squared. And just as an example, we're using the example where I drop the rock from the top of the cliff. If I drop the rock, that means my v naught term is 0. Because if I drop a rock from the cliff, its initial velocity from my hand is 0. I'm not throwing it down. So it starts with 0 velocity, and then I drop it, and then it starts to speed up because of gravity. So then this equation becomes x is equal to 1/2 at squared. And again, t is the thing I'm looking for. How long does it take to hit the ground? Well, I look at this equation and say, well, wait, now I have a quadratic term, t squared. It's still quadratic, but this is not a quadratic equation because I'm missing the linear term. I don't have a term in this equation, which is t to the first power. So how would I solve this? I don't have to use a quadratic formula here. I can if I want. If I were to use a quadratic formula here, then b is just 0. There is no v naught. V naught is 0. But instead, why do that? This is very easy to solve. First of all, get everything on one side of the equation. Or no, we don't even have to do that. All we got to do is basic algebra. Solve for t, get t by itself. How do I do it? Move the 1/2 a over to the other side. So x over 1/2 a is equal to t squared. But again, I don't want t squared, I want t. So to get rid of the square, I take the square root. And if I do the square root on the right, I have to do it to the left. So t is the square root of x divided by 1/2 a. So although this looks like it could be quadratic, because it doesn't have all three terms, it's not really a quadratic equation. And so I could do some other method to solve it a little easier. Quadratic formula is always a pain in the butt to solve because of the plus or minus thing. You got to do it twice. So if you can avoid using quadratic formula, that's nice. Here's another example of something that looks quadratic but isn't. Let's say we have, how about x squared plus 4x equals 0. All right, again, this looks like it could be a quadratic equation. The highest power on the unknown variable is 2. And then I have the linear term. But notice I don't have the constant term, the plus c at the end. So because of that, this is not a quadratic equation of the standard form. So how would I go about solving this? Well, I'm not going to use quadratic formula if I don't have to. I could use a quadratic formula. It's just everywhere I see a c, I just plug 0 in for c. That works. However, an easier way is this I can factor. Because notice, every term in my equation has an x in it. There's an x and there's an x. 0 doesn't count. We don't care about the 0. So if there is the same thing on every term in an equation, you could factor that thing out. So this equation becomes an x times what's left over once I pull one of the x's out. Well, the first term becomes just regular x. And the second term, I pulled the x out, so all that's left is 4. And that's equal to 0. Okay, so that's basic factoring. When you have like term or like variable on every single term, you could factor that variable out and then write down whatever's left. And so if I were to multiply this back out again, x times x gives me x squared. X times 4 gives me 4x. I get the same thing. And now the question is, how do I solve this problem? You may know already, but in order to, if you don't really remember, or just kind of how I think about it, when I see it, I say, this looks a lot like a different problem. And this problem is, what if I had the equation a times b is equal to 0? Who can tell me, what does this tell you about a and b? Anybody know?
One of them is 0.
Right, exactly. At least one of them is 0. Both can be 0, but certainly if you're multiplying two numbers, a and b, and the value is 0, then one of them has to be 0 for sure. All right, good. So what about this thing then? Notice this is the same thing. This is something, I'll call it A, and some other thing, I'll call it B. And so this says A times B is equal to 0. So for that to be true, either A is equal to 0 or B is equal to 0. It must be. So how do I solve it? Well, just do it. If A is equal to 0, that tells me X is 0. That's the easy one. Instead, if the B one is 0, then that tells me X plus 4 must be equal to 0. And of course, if X plus 4 is equal to 0, I bring the 4 over to the other side, and it says X must be negative 4. So there's my two answers. Again, I get two answers because there's a square here, but I didn't have to use quadratic formula. I could do straight factoring because this is an easy factoring thing. The X is common to both terms. So that's basic algebra stuff. A regular equation with one unknown, plug in the numbers, solve for whatever it is. Quadratic equation, so the highest term is a square, and then you have all three terms. Use quadratic formula, you get two answers. Then you have things that look like quadratics, but they're not. So either you do a straight up square root type thing, makes that easy, or you do the factor thing. Now, the last part of algebra that we're going to have to worry about is what happens when we're given a system or a problem, and that problem contains two unknowns, not just one. So far, we've been working with problems where there's only one thing we're looking for, the time or the distance or whatever. But it could be that we have let's say you're at the top of a cliff holding a rock, and then your friend's at the bottom of the cliff holding a rock. You throw your rock straight downwards, they throw their rock straight upwards, and at some point, the two rocks hit each other in midair. And the question is, where do they hit? How high above the ground will they make contact? Now, in order to solve this problem in first semester physics, it turns out that the way you have to think about it is you have to say, what does it mean for the two rocks to hit each other? What it means is rock one and rock two are at the same position. They moved to the same point, and they got there in the same amount of time. So at the same distance at the same time. Now, you don't know what the distance is, so you want to find out what it is. That's the answer. But also, you don't know when they meet. You don't know the time it takes for the two rocks to hit either. So if you try to use one of these kinematics equations, you're going to have the x is an unknown and the t is an unknown. You know neither. And so how do you solve a problem like that? Well, mathematically speaking, if you have two unknowns, then you need at least two equations to solve it. If you have three unknowns in your problem, you need three equations to solve it. You cannot do with fewer equations than unknowns. You can have more equations, that's fine, but you can't have fewer equations. So there will be some problems that we're going to get to where you're going to have two equations with two unknowns, let's say. So how do we solve something like that? I'll show you how I do it personally, but again, in math, there's other ways to do it. And if you know those ways, you're free to do it. Well, let's say we have something like this. 2x plus y is equal to 5, and then x minus 3y is -1. Okay, so we have these two equations. Let's say x is position, y is time, or something like that. I don't know. So somehow I've worked my problem down to, I'm left with these two equations with these two unknowns, and I need to solve for them. Well, if for any of you that's getting into physics and going down the physics route, when you get probably to the very next physics class, physics 309 or 310, I teach you the linear algebra way of doing this, where we use matrices. It's a fancy technique that's kind of fun to do. Since we don't know matrices in this class, I'm not going to teach that. I'll show you the way I do it normally, just basic algebra way, and that's called the substitution method. I have found that this is the easiest method in that it takes no thinking whatsoever. As long as you know what the rules are, you do the rules, you crank out the answer. You don't have to think about how to manipulate stuff. So what's the rules? The first step is choose one of the two equations and solve for one of the unknowns. Okay, it doesn't matter which you choose. You can choose the first equation or the second, and it doesn't matter which unknown you choose, first or the second, doesn't matter. So usually what I do is I look at my two equations and say, which one is easier to do? Well, if I choose the first equation, the y is the easiest thing to solve for because there's nothing on it. You just move the 2x over and y is just sitting there. If I choose the second equation, the x is the easy one to choose because the x is just sitting there, move the 3y over. So it doesn't matter which I choose. Let's say I choose the second equation. So here's the first equation, here's the second. I'm going to choose the second equation and solve for x. Okay. So let me rewrite it. X minus 3y is -1. Now I'm going to solve this equation for x. How do I do it? Move the 3y over to the other side. So x stays there, and now I have 3y. Remember, it becomes plus because it was negative on the left. When you move it to the right, it becomes positive. And then -1 is still there from the beginning. And there we go. I can't do anything more than that. If I happen to know the value of y, I could plug that value of y in here and I'd know x, but I don't know y yet. So say, okay, that's as far as I can go. What's the next step? The next step is now take that thing that you just solved for. X is now known as 3y minus 1. I don't think about it as x anymore. And go to the other equation, the one you didn't use. So I didn't use equation 1. And everywhere you see this x in that equation, replace it with what it's equal to. So, okay, 2x plus y is equal to 5. That's the equation I haven't used yet. There's an x in it. So instead of the x, I'm going to write 3y minus 1. Okay. But then I continue on. Everything else in the equation has to stay there. Plus y is equal to 5. Okay. Now look at what we have. Something magic happened. Now all of a sudden we're sitting here with an equation, this one right here, and it only has one unknown. No longer does it have two unknowns in it. This is nice because I can solve an equation that only has one unknown. This is no longer impossible. So let's do it. Let me simplify things because it's all messy. So there's a 2 on the outside of the parentheses. So you distribute it through. 2 times 3y becomes 6y. 2 times -1 becomes -2. Then we have the plus y is still sitting there, equals 5 is still sitting there. Collect the y's together. 6y plus y becomes 7y minus 2 is equal to 5. I want to solve this for y, this basic algebra. What do? I'm going to bring the 2 over to the other side. So 7y equals, I'm going to bring the 2 over, it becomes plus 2. So 5 plus 2 is 7. All right, solve for y. This is easy. Y is equal to 1. I now have one of my answers. I now know the value of y is 1. I still have 1 to go. I still need to calculate x, but now it's easy. I already did the hard work for x. Here it is right here. All I have to do is tell this equation what the heck is y. Well, I now know y is 1, so let's plug it in. X equals 3 times 1 minus 1. So 3 times 1 is 3 minus 1 becomes 2. So now I know x is equal to 2. And there we go. Here's an example. You're given 2 equations with 2 unknowns. Whatever x and y mean, whatever they stand for in your equation, who cares? I want to know both values. How do I go about doing it? This is my method. It's not mine. I didn't invent it, but it's the way I always do things because I could just straightforward do it. I don't have to think about stuff. Another method you may have seen, and I'm sure you've seen it in algebra class, is a lot of times the professor will say, well, look, what I would like to do is, let me go ahead and rewrite these over here, just so you can see me do it. 2x plus y is equal to 5, and x minus 3y equals minus 1. What you might have seen in the past is the professor will say, okay, I want to subtract the 2 equations, and when I subtract them, I wanted to get rid of one of the variables. So first of all, if I subtract the equations now, nothing will cancel out, right? 2x minus x, I still have an x. Y minus -3y becomes 4y, -4y, or positive 4y, I'm sorry. So that they won't cancel out. So in order for this to work, I first have to multiply one of the equations by something to help me. So I would say, okay, if I multiply this equation by 2, then what would happen? Well, now this is 2x, and instead of negative 3y, it's now negative 6y. And instead of negative 1, it's now negative 2. Okay, so I multiplied that whole equation by 2. Now, if I subtract these two things, what happens? 2x and negative 2x cancels. Y minus negative 6y is 7y. And 5 minus negative 2 is 7. All right, well, this is nice because now I know y is 1. There we go. I got one of my answers. And then how do I get the other one? Just like before, plug this y into here, and that'll give you your x. Now, I don't like this method for the very reason I just showed. Before I could use it, I first have to think about it and say, how do I have to modify one of these equations so that when I go to add them or subtract them together, something will cancel? That's just more having to think about stuff that I don't want to have to do. In this method, substitution, there was no thinking. You pick one of the equations, solve for one of the unknowns. It doesn't matter which one you pick. You can pick either one. And you could pick either unknown. Once you do it, you solve x is or y is equal to blah, 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 whatever it is. Then go to the other equation, the one you didn't use, and plug it in, substitute it in. No thinking, no preparing, none of that stuff. You're just cranking out the answers. And for me, what I have found is, let me use my brain thinking for how to set up the problems initially. What am I going to solve? Which equations am I going to use? That's where I want to use my brain power. Once I get to this point where I have these two equations and all I have to do is get the answers, as little thinking as possible. Let me just work out the rules and get the answers. But as I said, I'm not the kind of professor who's going to mandate you use a certain method over another method. Both methods here are legitimate mathematical ways of doing it. And as long as throughout the semester, when you do the math, you're doing something that's legitimate, even if it's not the way I would have done it, it's still perfectly fine. What's not fine is if you do something illegal, something that's not mathematically correct, and you happen by pure accident to get the right answer. Because maybe you did something wrong and it gave you a 2, but that's a coincidence. Doing it the right way also gave you a 2. Well, you didn't do it correctly. You did it wrong. Yes, you got the number thing at the end of the day correct, but it was a coincidence. Because if anything in the problem had changed, you would not have gotten the right answer doing what you did. So my way of thinking is, you're allowed to use any method you'd like, as long as it's a legitimate method. So it would work every time you do it. So that's the substitution method. And that's everything about algebra we're going to need here. Okay, basic, here's your equation, manipulate the equation to solve for the unknown. Quadratic stuff. And then systems of equations, 2 equations, 2 unknowns. If you could do these 3 main topics of algebra, then pretty much any problem we have in physics, as long as you set up the correct equations, you'll be fine. Now, you definitely should practice, because I think it's very easy for us to assume, because we were comfortable with it in the past, that we're still comfortable with it now. Even if we did it last semester, we just had a Christmas break, we took a month off, and maybe we took longer than a month off, to be honest, even during last semester. Our brain may be rusty in doing this stuff. Practice it, because the last thing you want is to work hard in learning the physics of a particular problem, and then you make a dumb math mistake just because you weren't comfortable with the math. It had been a while since you did it, and you just made stupid little mistakes. Why get those points taken off? Start now, practice them, get back into the mindset, and then you'll be fine, mathematically speaking. All right, any questions on the algebra we've been discussing so far? Nope, it's fairly clear and makes sense. I
No
tried.
questions just yet.
Good, perfect. I tried to, maybe I overanalyze things sometimes when I do the math stuff, or maybe I go and talk about it further than I need to. You may be completely bored as yes, we get it. My God, we've done this for years. But I know that for the most part, the math is where people in physics mess up. The physics isn't so hard, but the math part of it, you use a negative sign when you should have used a positive sign, or little stupid things like that. And so the more clear I can be, and maybe if I think about things differently than you've thought about them in the past, and it helps make it click better for you why things work the way they do, then I think it's worth me talking about them more than I normally would, let's say, if I were working this myself. Now, here's the plan. I'll let us off early because I think we did a sufficient job with the algebra. Next class, we're going to do the trigonometry and the vectors. But before then, I'm going to post, it's all posted, but I think I need to publish it on Canvas. As I discussed, I think last class, I have on the recorded lectures from last year's section of this course. For the math review, I have algebra, trigonometry, and vector videos posted. Also, the practice problems for algebra, trigonometry, and vectors and their solutions. So I'm going to post all of that or publish it so you can start watching it. If you want to move ahead, you don't have to watch the videos if you don't want to, but they'll be there in case you do want to. But the more important are the practice problems will be posted. So look at the practice problems, try them out, especially look at the trig and vectors ones, because on Tuesday, we'll talk about that stuff. And if you have particular questions in those two topics, then I'd rather spend my time working particular examples on what it is you're unsure about, rather than me just making up generic examples that maybe you already know about. So those will be there for you to start working on over the weekend, practice some problems, and actually practice them. Get out a blank sheet of paper and try working it, because just, if you're watching one of the online videos and you watch me work it out, the way I was as a student, when I watch a teacher working on the blackboard, it makes perfect sense. Every step they do, oh yeah, that makes sense. I know why you did that. But then when I had to do the problem myself at home and no one was showing me the steps, I'm like, ooh, I thought I knew what to do, but I don't really remember now. So sit down with a blank sheet of paper and try working some of the problems and make sure you're comfortable with it and you remember what we were doing. And like I said, if you don't remember, then those are the things you want to ask me specifically, because we want to get all the math questions cleared up these coming weeks before we get into the physicsy stuff. So expect that stuff. I'll post that today. Probably Friday, probably tomorrow, I will post the homework problems for math review, and that'll be due next week. I usually give a week to do homework. So if you're comfortable and you're confident with the math review stuff, you can go ahead and work the homework as soon as you want, but it won't be due till next week, till next Friday. So that'll be there. I'll also email when the homework's posted, just to remind everybody. But anyway, that's it. You've seen kind of how I do these online lectures now. If you weren't in my class last semester, so that when I do the poll about if you don't want any online lecture stuff, or if you do want online lecture stuff for this semester, at least now you could see what it would be like. Yes, we still meet at class time. You can still watch me work problems and stuff live and ask me questions. So it's not like I'm just going to post a bunch of recorded videos and have you watch stuff and there's no communication. But if you don't like it, then that's something you'll be able to tell me. And if you do like it, if you'd prefer it in that way, that's something you'll be able to tell me. I'll be posting that kind of poll or quiz, quote unquote quiz question, where I could get your feedback about such things. So again, I will email when that is on there as well. But I definitely wanted you to see what an example of how these lectures are done by Zoom before I ask you to make a decision. So that's all I have for you today. If you have any questions, of course, you're free to ask. If not, you're free to go, and I will see you next week.
Thank you.
All right.
Thank
see
you.
Bye.